What we're going to do today is talk about something that I don't think many of you have heard of. I was speaking to somebody, and some people have heard of them, but very few. This has to do with something called a methane hydrate. Now, you're going to ask, what is a methane hydrate? And I'll explain it to you, and I'll also explain why we should really be concerned about this. Now, what I have here is, this is a model of methane. I have my own set of organic beads and things like this to make models. And methane is a very simple compound, yet we have many derivatives of it. In fact, those of you who cook at home and cook with gas, unless you're using propane or something like that, you are using methane gas, which comes out of your stoves, okay? Now, methane, I'm going to show you what it is. It has a formula of CH4, okay? Which means it contains 1 carbon and 4 hydrogens. Yet, many of you have heard of the stuff you put in the cars to make your air conditioners go and refrigerators and things like this. Well, essentially, they are derivatives of methane, okay? And so methane is one of the simplest organic compounds that we know of. Now, what I intend to do, if we can get this computer working here properly, this one took forever to boot up. It's kind of slow, but I'd like to blame global warming on that too, but I can't. Okay, anyway, I blame global warming on everything, and by the way, the reason why I mentioned that is because methane gas is a potent global warming gas. Now, let me just get this thing going, and then we will continue. Lectures and okay. Methane Clathrates. We gotta wait till this thing lines. Anyway, so methane, what we're going to do today is talk about methane. And what is a methane hydrate? Essentially, hydrates mean contain water. Methane hydrates are water or ice molecules containing methane in them. And there is deep concern now because of this. First of all, I want to explain that methane hydrates are found all over the world, especially in cold regions of the planet. And what's happening now is methane tends to be emitted in the atmosphere. Methane is a potent greenhouse gas, okay? And how potent is it? Well, I'm going to tell you how potent it is. Carbon dioxide, as we all know, is the major greenhouse gas, okay? However, when we talk about greenhouse gases, we have to look at something called the global warming potential of these. Carbon dioxide has a global warming potential of 1. Methane has a global warming potential of 22, which means if we put out a lot of methane, let's assuming we have more methane than carbon dioxide, the ability to heat up the Earth is 22 times more than the equivalent of carbon dioxide, okay? So what I'm going to do today is show you a chart of a whole bunch of things related to global warming and the methane hydrates and why we should worry about it. First of all, I want to show you here some gases involved in the greenhouse effect, okay, of which methane is one of them, and methane hydrates causes them to be released. If you look up here on the chart, this is the greenhouse gas emission as of the year 2000. Essentially, most of the majority of the greenhouse gases, roughly 55%, is carbon dioxide. Nitrous oxide, which has the formula N2O, is the stuff that sometimes dentists give you when they want to pull your teeth or something like that. We also have high GWP gases at around 1% of 1, and I'll explain. GWP stands for global warming potential, and I have a whole list of them and the global warming potential of all of them, but I'll explain that too in a few minutes. Today, though, we're mainly talking about methane. Methane makes up about 16% of the greenhouse gases. Yet, it is very potent. It is 22 times more potent than carbon dioxide, okay? Now, let me show you, first of all, where much of these gases come from. Okay, anyway, here's the formula for methane. Again, this is sort of the three-dimensional chemical ball and stick model, you could say, of methane. This is another type, space filling model of methane. It has 1 carbon and 4 hydrogens. And again, this is a chart showing you the total greenhouse gases, of which we have carbon dioxide, CFCs. Remember I told you you have air conditioners in your car, and the gas used in your car is something, it used to be called CF12. Now they've changed it, but CF11, CF12s are actually derivatives of methane, okay, because they contain 1 carbon and 4 molecules. We took away the hydrogen and we added fluorine and chlorine to these things. Water. Water is a potent greenhouse gas, but it is very good for us, because if we didn't have a greenhouse effect, nobody here would be able to live, okay? In other words, we all have a greenhouse effect. That's what keeps the temperature in the moderate range, so all the organisms, at least those that live above the water and on the ground, can survive. Venus, by the way, also has a greenhouse effect, but as far as I know, there's no life there. I never met anybody who visited it there and came back. You know, I guess it's kind of hard to find somebody to go to Venus. But anyway, it's another story. All right, so it's very hot there too. Then we have a little bit of oxygen, nitrous oxide, and of course methane. Without the proper balance of these gases, we get out of balance, okay? So when we add too much of these gases, the world will heat up. Nature has made us in such a way that we were able to survive. Now, what I have here is a chart, and this is the chart that I wanted to explain to you, and then I want to show you something real interesting. This is a chart of the major gases associated with the greenhouse effect. And we see carbon dioxide has a global warming potential of 1. Methane is about 21. Different books say different things, but 21 is probably the most accepted number. We have nitrous oxide, again, laughing gas, has a global warming potential of 310. Chlorofluorocarbons, again, these are the freons, well, not the freons, the refrigerants you use. They have about 1,300 to 12,000 times the global warming potential. And by the way, this tells you the roughly a percent in the atmosphere. Then we have perfluorocarbons. These are fluorine-based carbon compounds, and some of those get emitted into the atmosphere. Even though we don't have that many, we have roughly, they have a global warming potential of 7,300 to 12,000 times. And then the master of them all is sulfur hexafluoride. That's SF6, okay? This has a global warming potential of 22,800 times. Now, I want to show you something with sulfur hexafluoride before I continue, because I feel this is sort of a novelty and something that you should be interested in. In my research, I was checking various compounds, and I ran across this particular internet video tube presentation on sulfur hexafluoride, and I just want to show it to you. Fortunately, they only make about 6,000 tons of this a year. And if we had so much sulfur hexafluoride in the atmosphere that we do methane or carbon dioxide, I don't think anybody in this room would be alive today. You would all be literally cooked. Okay, let me show you this. And again, I'm showing you this just to show you something that I think you will find interesting. I'll open it. I want to get to go to Google. I don't think we have any of that on campus. Somehow I can do that mixed up. Okay. Just want to, I think you'd enjoy this and get it working. The computer is slow. It took about 20 minutes for it to boot up. There we go. Okay. Sulfur hexafluoride. Now, showing you this because, again, it's quite interesting what you're going to see. Now, you all know what happens when people breathe helium, right? You talk like Donald Duck. Well, this is just the opposite, and I'm playing it for you because it's, okay, let me show you. There we go.
All right, so this tank over here, it even sounds different when we fill it up. So here, listen to this. It sounds different. So it's heavy. And you feel this, it feels heavy too. Just as you rock this back and forth, you feel it.
Oh, yeah.
So this
It's
is
like a pool of water. Almost.
Yeah.
It's got water in it. It's got weight.
And it's just gas. All right, so the same thing you're going to do, but here's what I want you to do. I want you to all your air goes out, and then breathe in, and then I want you to do the intro to the podcast. Ready? Just tell our listeners at home something of importance. Ready? Here we go. He's bringing in the air. There's the sulfur hexafluoride right into his lungs.
Oh no, you don't snatch the brain so 51!
See, now you can do that with some sort of, you're really doing that. You're not, there's no trick behind the scenes or audio.
Post-production.
Is that, it's still in your lungs, isn't it?
It's still in my lungs, but it's coming out.
Yeah. Okay, now breathe in. You're going to have to push it back out again. You're going to have to do that a couple times because that's your gas.
I'm almost there. I'm almost there.
One more.
Okay.
There it is.
Hello, y'all.
You're back.
So anyway, just wanted to show you that. So that, it just shows you, it's a special gas, okay? So anyway, I just wanted to point that out, that's what happens to you. And what they did farther in the movie there, they put it in a fish tank and they floated a little boat made out of aluminum foil, and it floated, and the guy took a cup. You wouldn't see it, it would just go down because you take it out just like liquid water, you understand? So anyway, it's a very heavy gas and it absorbs the heat 22,000 times more than carbon dioxide. So anyway, that's why I'm showing you this, just to give you some examples here. Okay, now, so this is the chart of the global warming potential. Now, where does methane come from? I want to explain this too because this leads us up into more of the detail. Methane comes from all these. We have, first of all, anthropogenic influences, which means produced by human beings. You see that? Humans, anything anthropogenic. We all know that if you want to study mankind, you take a class called anthropology, right? Okay? And hence the term anthro means human, all right? So now, we have ruminants. Ruminants are cows, okay, because they have a special digestive system. Humans too, and other animals too, but cows produce a lot of flatulence, which comes out as methane into the atmosphere. That has to do with domestication of animals. Then we have rice paddies. You get a lot of methane produced in rice paddies because of the anaerobic conditions under the ground, because you need to plant the rice in the water, and that produces a lot of methane. You have biomass burning, and what biomass is, that means burning down the trees, and I will show you pictures of these in a minute. And when you get biomass burning, you also get some methane being produced. Landfills, those of you who've ever been to the main campus in Des Plaines, at night you'll see lights flaring across. There's a landfill there, and you'll see they burn it, and the gas that's coming out is methane, and they're burning the gas. So it's also produced underneath the ground, the decomposition of garbage. Then we have coal mining. Coal mining produces methane, as we all know. What happened a few weeks ago, the explosion, remember in the mine in West Virginia? That was probably caused by methane. Mining is very dangerous because under the ground you have a lot of methane gas. And then in the process of gas production, when we take refineries and things like that, you're also producing methane. So these are all mainly human sources. Then we have the non-human sources, are methane hydrates. That's what we're going to talk about today. Though we have it in fresh water, okay? Sometimes we have organisms that are decomposing, such as in wetlands and things like this, and we get some methane from there. Ocean water. This is part of the problem because a lot of this is seeping up from the ocean, and I'm going to show you pictures of this. And then, of course, we have wetlands. Wetlands produce a lot of methane because you have a lot of productivity there and a lot of animals, and you have decaying vegetation, things like this, which will cause methane, and of course termites. Why termites? Because when you cut down the rainforest, you're going to get a lot of termites, and they gobble up the wood, and in their digestive systems, they produce tons of methane as well. So these are the major sources of methane gas. Now, this is a picture of methane hydrate burning. All they have to do is take some of these ice-like crystals, and light them. You see? Essentially, a methane hydrate is found in the ground in cold areas, okay, of the planet. Under the water, by the ocean, and I'll show you a map of where most of them are found, okay? They're usually found in cold regions. Now, isn't it amazing? You take some ice and then light it, and this is what you will get, okay? This is very bad because with global warming, what's happening is the ice is melting, releasing all that methane gas, which is the last thing that we need. Now, here are some of the pictures that I showed you from the human-made resources of methane. Here we have a landfill. And by the way, we have a lot of garbage dumps, and people put their garbage there. And by the way, I don't know if any of you are aware of the fact that many of you do not know that the garbage business is a good line to get into because business is always picking up. I just thought I'd share that. Here we see burning in the forests. Here we see cows, the ruminants. You know, they have something like 5 stomachs, okay? And what happens here is they produce a lot of methane in their digestive system. Okay? So cows, and this is a problem too. I want to point out that I think now there are about 56 billion domesticated animals on the planet, and of course most of them are for food. Now, as China and other countries are becoming more wealthy or wealthier, they all want to go to a meat diet instead of the vegetarian diet that they had previously, which I find to be very bad for a number of reasons. Not only health reasons, but because of the atmosphere. They're putting out all that methane gas, which is not a good thing. But anyway, I didn't come here to talk about that. Here we see rice paddies in Asia. Okay, they produce a lot of methane gas. And again, this boils down to a population problem because rice is the staple in many of the countries in the world, especially in Asia, and they have quite a large population, okay, with India having about 1.1 billion people as we speak, and China having 1.3 billion. So between India and China, they have roughly 1/3 of the world's population of about 6.8 billion. Here we see mining, okay, coal mining, and of course there's lots of problems with this. All this boils down to energy, and I just want to say one thing, that here on the planet, the major problem humans have is an energy problem. We go to war because of energy, we cut, chop, and dig up the earth because of energy, and of course that's not a nice sight. So we're just putting holes in the ground, and of course we're releasing also lots of methane gas. So there aren't any really good uses of coal now that we have the sun and we know how to harness it properly. That's another story. Here we see gas manufacture. This is some sort of refinery where they make gases, and of course they produce methane as well. Here we see termites. These are the ones that gobble up the wood in the rainforest. That comes from the chart that I mentioned before. And here we see wetlands with all the birds, and then we see a lot of, there's going to be a lot of decay here and giving off a lot of methane. Now, here is what we have here about methane hydrates. Now, here we see is something in the Arctic region here. And what you see here is we have sea level here. And what happens is the gas hydrates are stable at Arctic temperatures. You see that? They're in the ground, they're more or less stable. However, once you have global warming, what's going to happen is they're going to start bubbling to the surface. Okay? And that's very bad. And they actually took pictures of seeing bubbles of methane gas being emitted from the ocean, okay? And this is very bad because this goes into the atmosphere and you're going to have problems. Now, speaking of water bubbling in the ocean, there is something real interesting that you should be aware of. Those of you who know Archimedes' principle, says, that's why boats are able to float, right? Something to that effect. However, there's a theory now that you can sink ships by putting a lot of methane in the water because that lowers the density, you see? So what's going to happen is boats, if all of a sudden a big boat can even sink because of methane gas in the water. You understand it lowers the density of the water, you see? And that is one of the theories of the Bermuda Triangle. Now, this is just a theory that there was a lot of methane gas and that bubbled up and somehow that caused the ships to sink. Okay, you can do research on this. There are many websites that talk about this. Now, some people say it's baloney, but anything's possible. I even discussed this with some Navy personnel, because I teach over at Columbia College of Missouri up in Gurnee, and a lot of our clientele are Navy personnel from the Navy base there, and one person told me that's a possibility. However, to sink a giant boat like an aircraft carrier or something like that, you would need a lot of methane in the water to do it, but in theory it's possible, okay? And so this is one of the theories for the Bermuda Triangle and its disappearance. Now, if we look at the global average of methane gas, we see it has gone up a little bit, not to the extent of carbon dioxide, but nevertheless, it's on the rise. And what's going to happen is, as we have a spiraling effect on global warming, we're going to heat up the hydrates located in the colder regions of the planet, such as the Arctic and Antarctic, and that'll cause more evaporation, and then this is just going to spiral out of control. And we know about this now. This is not some science fiction movie. One of the areas that they're mainly worried about is the East Siberian Sea Shelf up here by the former Soviet Union, okay? There's been a lot of research done on that particular area because this is known to leak out a lot of methane. Now, here we see a picture here about this, okay? We have, here is the East Siberian Arctic Shelf, okay, up in the former Soviet Union. And what's happening is permafrost is beginning to melt. Now, permafrost is the soil that's basically frozen all year round, hence the term permafrost. For many of you who have seen Al Gore's movie, An Inconvenient Truth, they showed pictures of the permafrost melting. And one way we can see it melting, we don't really see it melting, but we see the effects of it, such as telephone poles are now leaning to the right because they used to be in hard ground. Now the ground is melting, it's soft, and the poles are turning, and they're slowly coming out of the earth, okay? And that's because the permafrost is melting. When the permafrost melts, you're getting sort of a double whammy here. You're getting more carbon dioxide being emitted and more methane being emitted. So global warming is just enhancing and causing these things to spiral out of control. It's also known, by the way, as a threat magnifier, because those countries that are already on the verge of total collapse or have some problem, it's just going to increase their collapse. So the global warming is a threat magnifier. Now, if we look at this picture, this is actually one of the best pictures I've ever seen. If you look closely, methane, which was normally held at the bottom or at the very cold regions now, is leaking. In other words, from the methane hydrates, a little ice mixed with the methane gas. So it's coming up into the atmosphere at very large rates, okay? Again, this represents the area up by the East Siberian Arctic Shelf, which, by the way, has an area of about 2 million square miles, okay? So it doesn't take much imagination to figure out what could happen when you have such a large area like that, leaking methane from the methane hydrates that are in the ground, okay? Now, here we see another chart relating to the dissolved organics, okay, and gas hydrates, okay? And this shows you the relative number, okay? You know, fossil fuels, there's only 5,000. Again, these are in gigatons of carbon, okay, which means it's 10 to the 15th power, 1 gigaton, which means it's quite a bit. So we have fossil fuels, which include oil, coal, and gas, okay? But you can see with the gas hydrates, specifically methane, you see double the amount. You see that? So that's quite a bit there, okay? So that's something we have to be concerned about, and it's about time that we do something for it, about it. Now here, we see known areas where methane hydrates are found in both the sea sediments and the permafrost. So notice, of course, you find a few even in the tropical regions because that's way under the ground. But up here in the northern area, you see a lot. And it is here, the Siberian Arctic Shelf, the East Siberian Arctic Shelf, known as ESAS, is right here that they're mainly concerned about, okay? So, this is really a severe problem. Now, what is being done about this? Well, I'm going to tell you what's being done. Unfortunately, not a lot. I want to read something to you. Now, I didn't make this up, okay? I was doing a lot of research here, and again, I don't mean to get political, but I did find a lot of research here, and I want to explain this to you. Notice that, that the world now knows about this. How come no one in this room ever heard about it? Has anyone here in this room ever heard about it?
Methane?
No, methane hydrates.
Oh, no.
Okay, why haven't you heard about it? Because evidently it's not making the news because they're more concerned with Tiger Woods and missing girls and all this other stuff, right? Which really has no relationship to the health of the planet, okay? You know I'm right, because I'm sorry to say this, folks, but the newspapers are dumbing you down, okay? I'm just telling you the truth. The real issues are not being discussed. Now, let me read this to you. You're going to be amazed at what I have to tell you. And again, this is not my words. It says here in September of 2001, that was, remember, Bush was president, right? It says the White House held a secret meeting about what to do in the event of a sudden, abrupt climate change. Before the idiot Bush, he said it, I didn't, labeled climate change junk science. You see? Before, they had the meeting before Bush declared climate change as junk science. They had a meeting. You understand? And so, did you ever hear about that from President Bush? Of course not, because it's not in his interest. You see, he's out doing other things which have nothing to do with saving the planet. However, things have to be done. Now, what's being done? Let me explain here. It says, according to this author, President Obama cannot ignore this subject for another day. He must immediately call James Hansen, regarded by many as the world's leading climatologist. James Hansen was one of the scientists, I believe he worked at NASA, and he was an expert on climate change. And as a matter of fact, when he was in charge, he wrote a paper about the effects of global warming and climate change, and the administration under Bush didn't like what he wrote because it was too potentially abrasive or too damaging to the administration about global warming, and it caused a real uproar. So they had to dilute it down. And this is something we cannot tolerate, because if we don't do anything now, there's not going to be anything left. Does that make sense? Now, I don't want to scare you all about this, but this is a real severe issue. And like I said, methane has 22 times the global warming potential of carbon dioxide. And if we don't do something now, we're going to be in deep trouble. Now, to aggravate the situation, again, we're cutting down the rainforests. I want to point out something to you. And what's that have to do with this? I'll explain it to you. For those of you who don't know chemistry, I want to write something on the board here. And I'm going to give you an equation. When you burn methane, and by the way, you can burn it, since it's a hydrocarbon, you get CH4 plus oxygen. You use the oxygen when you burn it. You know what you're going to get? Carbon dioxide and water. So, many of you say, well, why don't we just burn it? Okay, now we have to balance that. Let's see, 2. Now we'll put a 2 here. And that's about right. Okay, we have 1 carbon, 4. We have 4 oxygens, 4 oxygen. There we go. Okay, that's about the balanced equation. And if you even burn it, we can't burn it, because if we burn it, we're just spewing out more carbon dioxide. So what we're doing is we're lessening the global potential, but we're still putting out more carbon dioxide. You see that? So in case those of you who thought maybe we could burn it, that's not really the solution, because we'll just be adding more carbon dioxide. So this is a real severe problem. And we should have started years ago by eliminating fossil fuel burning and going directly to the sun. Okay? Because this is really something that has not been mentioned upon, and this is real crucial. As a matter of fact, those of you who were around in the 1972, I think ousted, you and I were around in those days, right?
Yes.
We had, 1973 actually, we had something called the gas shortage because of the Arab-Israeli war. They used the excuse that the Arabs would not supply us with oil. And now it is about, if my numbers are correct, 37 years later, and we're still in the same boat that we were 37 years ago. We still depend on fossil fuels to drive our cars and stuff, which is the major one of the major producers of CO2. So what does that tell you? We haven't learned a damn thing, and now it's almost too late to do anything. Now, I'm not sure how late it is. I hope we can do something. And that is why we should have started yesterday in changing our energy requirements from oil, coal, and gas, and converting directly to solar, because that is the solution. And if we wait too long, it won't matter how long we wait, because there won't be anybody left to apply those new ways of preventing a situation like this. Now, those of you who are really interested in more on methane hydrates, you can read a lot on it, but I have a feeling in the future, unless we do something now, you're going to hear about strange occurrences too, like maybe explosions over the ocean because of the methane gas, ships sinking, things like this, okay? I know it sounds like science fiction, but nevertheless, I believe there is something that should be done immediately. Now, I don't think here we see a picture of methane hydrates burning again. And by the way, another term for methane hydrates are called clathrates. If any of you have ever seen that, it's called a clathrate. And so that's another term for methane hydrates. And let me see, I have something here I should show you. Let's see. Okay. This comes from Wikipedia. I just want to show you this, and then I want to mention one more word, a strange term that I want you to be aware of, and then I'll ask some questions. There it is. Okay. A methane clathrate is another name for methane hydrates, and another name for that, of course, is pyrite. It's a solid clathrate, and which large amounts of methane is trapped within a crystal structure of water. Okay? So that's essentially what a clathrate is. I didn't want to use that term here, but just a little bit, just so you're aware of what that is. It's the methane trapped in ice. Now, there's one other term that I want to make you aware of, and it's called a talik. A talik is a Russian word. It's a layer of year-round unfrozen ground that lies in permafrost areas. Remember, permafrost is the soil that's permanently frozen, and a lot of that permafrost contains methane hydrates. Now, a talik is unfrozen ground, and the problem is now, the scientists are worried that these taliks, which are above the permafrost, which are near the permafrost, are going to become more and more because the permafrost is going to melt, and it's from these taliks that you're going to have the leaking of methane gas. So the more taliks, the more danger we're in. Okay, and again, talik is a Russian term which means to melt. You see? Okay, is that right? You know the term, Victoria?
Tide.
Do you pronounce it tide?
Tide.
Well, that's the word we call it a talik because it's easy. Yeah. Anyway, there's our resident Russian expert here for us. Okay, so anyway, that's all I have to say about this, but the one thing we should do is we have to notify the politicians and the newspapers and quit fiddling around with nonsense, like who cares about the sex life of movie stars, golf players, and all this. And, you know, sure, they have crime and someone's missing for months, things like this, but these are the real issues. Do that make sense? These are the things we should be concerned with and not this other stuff, because there's no money in this, obviously, right? But here's the point. Now, I'm a hellraiser, folks. I'll tell you this. This is much more important than raising money, you know, or having something that, like on Oprah, she should talk about this instead of this other things, you know. I would say over 90% of stuff she talks about has nothing to do with the environment, you know, hair makeups and this and that and crime and stuff like this, which is fine, but I think she should spend a lot more time on this because people listen to her, right? She's probably the most influential woman on the planet, and you can catch her all over the world on cable TV. I know because I lived in Israel, and you can see Oprah on TV there too, by the way, just to let you know. So she's very influential, and so I think these shows where they have influential people should really raise hell. I understand David Letterman also talks a lot about the environment, but I don't think he does enough on that either, because his show is mainly not about the environment, it's to interview people that have nothing to do with this. And it's all, what is it? It's all a show business, to put it bluntly, and that's where the problem is. And again, I'm going to stress one more thing. We have to get the newspapers and the TV stations involved. Instead of dumbing down America and talking nonsense, they should talk about the real issues, and then maybe things will turn around. Because if people don't know about this, nothing's going to get done. Does that make sense? That's why I mentioned this. Okay, are there any questions, comments, anything? Are you all going to be able to sleep tonight? Yes, sir.
I was just wondering, how come you pointed out solar, but you didn't get into wind much, or alternative water energy?
Yes, that's a good answer, right. And the reason is, I know about wind energy and other sources, but we have, the sun is the easiest to harness now. It is. The trouble with windmills, and I'll get to your, I'm glad you asked, what's your first name, by the way?
Creighton.
Creighton?
Yeah.
Good, I'm glad you asked that. You see, I'm a real proponent of solar. To me, that's the only way to go. Let me explain about wind. Wind is all fine and dandy, right? But what do you need for wind? You gotta get the equipment, you gotta melt the metal to make the turbines, you gotta put in the wires, you know what I mean? You gotta cut, chop, and dig the land to put in the cement foundations and things like this. And if you ever see what a wind farm looks like, I mean, they have hundreds of windmills. It looks pretty ugly, actually, too. You destroyed the environment in a way. You know, you probably a lot of birds get killed because they don't see it.
And bats.
What's that?
And bats.
Bats too, right.
Those off that sonar.
Yes, sonar, you're probably right. It's no good. It's like a feel-good thing at the moment, but it's not really good. Solar, Craig, do you know what the biggest wasted space on the planet is?
Rooftops.
Rooftops, yeah, you were in my class, right? Yeah, he knows because he was in my class. That's right. He's in my class now, right? Yeah. Over at the Gurnee. See, rooftops, the biggest, even this building. Rooftops, you just put solar panels on them, and they have them now. Now, for those of you who saw the movie, Who Killed the Electric Car? Did you see it?
No.
They have some, now they coil them up real simple. They showed you, they have these new solar panels now that are almost paper thin, and you can get electricity from them, you see, and now they're working, trying to develop all this. But that's a feel-good thing, you know, why not use even wave power, which they do now have too, wave power generators, and windmills, which you see how ugly they are. You need a lot of, first of all, you need to maintain them, you gotta melt the metal, it takes a lot of energy to make them, don't forget, right? You've seen hundreds of them. So wind, okay, it's an alternative, but I don't think it's that good. Dams, by the way, are the worst.
Yeah, I wasn't referring to that.
Dams are terrible because they take up a lot of space. You got to flood a lot of land, and when you flood the land, how many people think about the animals being killed, the bacteria, the plants? And with dams, I just want to mention something. True, you're supposed to get free energy, but look at all the effort it took. How many organisms are dying because of that? And another thing with dams that most people don't know about is that there's the possibility of causing earthquakes because of dams, because of what happens is you have all that water piled up in a small area, and that weighs a hell of a lot. And if you're on a fault zone, that's enough weight to move the fault, you see? So that's the big problem there too. So wind power, its biomass is absolutely out of the question. Why? Because a biomass, you heard what that is, where you take either plant material or other things from biological organisms, and how do you get the energy from? You got to burn them. And when you burn, you're always producing carbon dioxide, you see? And I don't think the media tells you this. The only thing with biofuels, remember with ethanol, what did you see? You saw dollar signs in the corn growers, right? That's all they care about, more money, right? But they don't realize that when you raise the corn to make ethanol, you're causing more people to be hungry because the price of corn goes up and the price of food goes up. You understand? And so the poor people who normally would eat corn-based plants like tortillas in Mexico and things like that, when they double and triple the price, many of them can't afford it, you see? All because of the greed of the farmers who want to raise so-called cash crops, which they just get for money and not to help the people. Does that make sense? So that's another problem. So for me, the best way to go is solar. And we could have done it years ago. But of course, we're dilly-dallying, and when the newspapers don't even mention things like this, you know, kids read the papers, they see these TV shows with these new games, what, PlayStation 3, 4, 5, who knows? In the next 10 years, there might have PlayStation 25 come out. But the point I'm making is, you know, they made a big deal at Walmart, and everyone rushed to Walmart, quick, let's be the first to get it. How about getting a book about how to keep the world green, you know what I mean? That wouldn't sell, you know what I'm saying? That's why we've done that. Another thing, what was it? I'm going to tell you this because it's heard on the radio. Remember the riots they had in Los Angeles after the Rodney King verdict? You don't think any bookstores were looted, do you? No. The point was not one bookstore was looted, but the TV stores, you know, all this other electronic stuff was looted. So, I mean, if you're going to have gangs, you might as well have smart ones. Let them go, you know, loot the bookstores. But, as you know, that didn't happen. You see my point. And this is why I'm really angry at the newspaper and the media. They don't give a damn, to put it bluntly. And I'm sorry, I'm real blunt. I tell the way it is, at least the way I see it, because I've been around. You know, I'll be 65 in June, so I think I'm the oldest person in this room, so I've been around, okay? And as I tell my students, if I want your opinion, I'll give it to you. Okay. Now, are there any other questions? Yes, sir.
I read a lot on global warming, but it was stated that it was really a myth, that this is just a process that the Earth go through.
Right, okay.
It's been around for about several billions of years, right?
That's a good point.
And it's going through this process, not, you know, millions of times before.
Okay. Let me answer that. I'm going to give you, what's your first name?
Rodriguez.
Rodriguez, good. I'm glad you mentioned that. I think, you see what they're trying to do. I don't want to get political here, but I think those members of the so-called R party, I don't have to tell you the name, want to make this a myth, you see, because it's going to hurt their business. You see the bottom line? You understand what I mean?
Yeah.
If they have to do something, and that's going to hurt business, well, we can't have business hurting, right? So I'm going to show you something which I think will disprove your, what they said. I'm glad you mentioned that. Now, let me show you something. If I can get this thing up here. These computers, they have to clean out if they don't get to this room. Okay, let me show you what's going on. I'm going to show you right now that why I think they're wrong. And that's cars. Yeah, the auto show. I got free tickets once to go there. That's the only time I would go. Anyway, I'm going to show you something. I can get it up. Let's see, there it is. Get up there. I have a list of when do you think the 10 hottest years was since 1880? Take a guess.
2005.
Yeah, somewhere around there, right. Now, hold on a second. Try to get this. I have all the information here, if this thing will let me go to it. It's kind of slow today. Now, this computer is kind of old. Come on, there it goes. Come on, go, 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 go. Come on. You know why it's taking time? Because I want to hurry it up. Come on. Have here, get it, let's go down to page 85. There, okay, see this chart? Now, what does this say? It says here, if one looks at the literature on global warming and climate change, he will notice that the 10 hottest years on record since readings began. What year is this, Rodriguez? 1880. How many years ago? 130, right? I'm sure thermometers were pretty good in those days too, folks. It may be different by a fraction of a degree. Were the following in ranking order, starting with the warmest. That's right. Mark got it. 2005, 1998, 02, 3, 6, 7, 4, 1, 8, and 97. You see? So, is that sunspots or whatever they tell you, Rodriguez, right? They want you to think it's a myth. But I think it's a myth that they think it's a myth. You know what I'm saying? Now, there's a lot of literature on this, okay? This I got from the World Watch Institute. You see it? The hottest year so far was 05. Now, remember, What happened in 1995? Anybody been around? Remember the heat wave in Chicago?
Right.
That's not even on the list. So what does that tell you? They were hotter than, you see? Remember the heat wave, what, 700 senior citizens died because of the heat? You see it? Okay, so I think this should dispel the myth. Now, here's the point. Let's assume that they're right, right? Let's assume, just say, be the devil's advocate, as they say, or whatever, or the advocate, whatever. If it's true, it's still better to err on the side of caution. You understand? Let's still do something about it, because we don't know 100%. Okay, you understand? It's better to make a mistake on the positive side. Does that make sense? You see what I'm saying? So don't believe them. And you figure out who's telling you that. What, Sean Hannity, Rush Limbaugh, all these other guys, right? Which are known for their extreme right positions. And I don't mean being correct, you know what I mean. You know, right, they're all the way so right that they're wrong. You get the idea, right? You see the point? But I'm glad you asked that. So I didn't make any of this up. See, by the way, what you just saw here, I give it away. We are in the process of finishing up another book for those of you who are interested. I wrote a book on the environment, you know. I guess some of you don't. I just happen to have one here. Or I put it in my drawer upstairs, yeah. It's called The Earth is My Patient, and it's about the environment. We're doing another book now, written by 2 doctors, myself, and an illustrator, about diseases caused by climate change. And this is stuff you see in the book. The major part was written by a doctor who teaches at this campus, by the way, just so I let you know. So we're doing another book, and we mentioned this about the environment and the effects, you understand, of global warming and why we are susceptible to more diseases. And by the way, I want to point this out too, that with the increase in temperatures, you're going to see more dreaded diseases now. Why? Because you're going to see more vectors, and a vector is something like a mosquito or tick that carries the disease. And you know, people can be vectors too. Are you aware of that? People can carry disease too. You know, in a way, that's what happens. If somebody gets sick, they spread it around, right? Okay, you know what a vector is, right? It's a mosquito. As a matter of fact, there was an interesting story about that. When I was in one of my classes a few years ago, here at Oakland, a lot of people were getting sick. And we traced it back. Every time this guy, his name was Victor von Banowski, he would come to class, and people would get sick. So we found out he was the vector of this cold or flu, what was going around, so we called him Victor the Vector. Okay, now, are there any other questions? So just one more thing about global warming and the hydrates. As you can see, I hope I made the point that you understand methane is very potent greenhouse gas, okay? And of course we have the other ones, but with 22 times the ability of carbon dioxide to heat up, it's a good thing we don't have a lot more of it. And God forbid if we had that sulfur hexafluoride there, okay? Now, before we leave, I want to show you the rest of that sulfur hexafluoride, because I think we have 5 minutes and I want to use every minute possible. I wanted to show you this because I should have continued, but I just wanted to show you that part. Since we have time, I'm going to go back to this sulfur hexafluoride, and I will cut it off after the guy talks with a low voice. You know what? Sulfur show you the boat. I meant to show you that.
All right, so this tank over here, it even sounds different when we fill it up. So here, listen to this, it sounds different. Tell our listeners at home something of importance. Ready? Here we go. He's bringing in the air. There's the sulfur hexafluoride. Right into his lungs.
No, you gentlemen, snacks for the brain episode 51.
See, now you can do that with some sort of, you're really doing that. You're not, there's no tricks behind the scenes or audio.
Post-production.
Is that, it's still in your lungs, isn't it?
It's still in my lungs, but it's coming out.
Yeah. Okay, now breathe in. then you have to push it back out again. You're gonna have to do that a couple times because that's heavy gas.
Almost there, almost there.
Yeah, one more.
Okay.
There it is.
Hello, y'all.
You're back.
You don't see anything there, do you? Nope. Why? Putting an aluminum boat? I don't think that was fake, you see? So that's how heavy this stuff is, okay? Sulfur hexafluoride is quite heavy. Anyway, so you can imagine, if we were, I think, like I said, there's only 6,000 tons a year produced of that stuff. So can you imagine what would have happened if that much sulfur hexafluoride was put into the atmosphere, as much as carbon dioxide or methane? You could put an egg on this table if you leave it outside and cook it in a minute, right? You see? Remember, 22,000 times global warming potential. Okay, so this was just something to make you aware of what's going on. And again, here's the molecule of methane. Okay, any other questions, comments, anything? Okay, yes, sir, one.
The methyl hydrates, how do they know how much there is in the world?
They do an estimate. It's just like, you know, you have the geologists. They can figure out, they take a measurement of how much is in a local area. They look at the climate and temperature and things like that, and then they can figure. There's many gigatons out there, just like the oil reserves, you know. How can they really tell how many billions of barrels are there?
They can decay organisms over millions of years.
Yes, that's what happened to the methane. Right. What happens is the methane is a production of decay and things like this, okay? That's why in the landfill you get a lot of methane gas. And what happens is it got cold. Remember, when the planet was forming, it was cold and hot, right? Remember? You had ice ages many years ago, and then you would have something like stratification. The methane would be trapped in the sediment there, and then you'd have other soil on top of it, and it would be very cold in certain regions. And then you get melting. So we've had global warming episodes before during the years, you know, as Republicans would like you to believe, you know. But it could be natural, it probably is, but based on what we know today, with the last 10 hottest years fell in the last 20 years.
How do they explain the disappearing glaciers?
Well, that had to do with, because, yeah, you know, the Earth rotates and you have tectonic plate movements, things like this. You had a question?
Yeah, I think it's safe to say that humans are basically the biggest contributors to the increase in methane gas, right?
I would believe that, yes, because of cows.
Right,
And
because
that's
of
part of
cows
it,
and
right.
rice paddies and stuff like
Exactly.
that.
But see, the higher the population, and by the way, as we
Right,
speak,
that's
right, and I want to tell you one thing, for those of you who don't know, every second, and you can look this up, there's a lot of literature, 5 minutes are born, 2 people die, net gain, 3. So we've been here roughly an hour, 8,500 people were born since we began this lecture today. What do you make? Actually, were added to the earth. More than that were born, but 2 died, you see, to give you a net gain of 3. And there's a good website that shows you this up there. I don't want to put that now, that's good for another lecture. But we have too many people. Well, okay, I won't say too many. Everybody who's here now should live nice and well. But we have too many cows. There's no reason to eat cows when you can eat grain and things like this. Because one other thing, for every pound of you eat, you need 10 pounds of food. So if you eat a cow, that's the equivalent of eating 100 pounds of food, because that's to raise the cow. You need 10 pounds of meat to get 1 pound, to gain 1 pound of you. Well, so you see, there's like a 10-to-1 ratio. If you skip the meat, you go direct to the grain, because if you ate 10 pounds of cow, that's equivalent of eating 100 pounds of corn, if you know what I mean. You can get the same thing of eating 10 pounds of corn. See it? I don't know if that's confusing, but anyway. And again, the majority of grain goes to feed the animals. You know, most animals we eat are vegetarians. So just thought I'd let you know. Then you have more people to feed, and then the more wealthier the people are, the more they want to change diets to meat, which means you're going to need more cows, more. It's a spiral. See, now China, you know, they are becoming a superpower. You know that. They have now many cars. Did you know about 20 years ago, there was 1 car for every 220,000 Chinese? I know, I keep track of stuff like this. Now, there's a lot more. I mean, there's about, what, I don't know, quite a few. Maybe every 5 or 10 people have a car, something like that. In America, it's 1 car for every 1.5 persons. You know. That's the way it used to be. See, I keep up on stuff like this. Anyway, are there any other comments, anything, questions? Okay, folks, I want to say thank you for coming, and this was nice meeting you.